have a lesson about the curved mirror, how they are used for different types of reflecting the light rays. We had before the plane mirror, and we said the plane mirror always producing for us a virtual, literally, image, and also the image has to be the same size of the object, and the image is not real, it's virtual because it's made by the extension of the light rays when they are reflected. Today's lesson we will speak about how the concave mirror being different from concave shape. Second, we have to know the diagram which shows the light rays when they are converged or diverged by the concave mirror. And the last part, we have to explain how the curved mirrors can have a variety for usage in our society. The first part here, we have two types of the curved mirror. The first one, when they are curved inside, we call it the a concave mirror, like a cave. And the second one, when it curves outside, we call it the convex. You have to know here that inside a concave mirror, mostly of these light rays that falls on this mirror are converged. When you are using the concave mirror, the light rays will be concentrated into a point. Some of the light rays might be erect or causing inverted images, or the last part can be a magnified image to be formed. All of the light rays, when they are coming away from any object, when they are falling on the plane, on the mirror, they have to be parallel light rays, and when they are reflected of this mirror will be converged at the point we call it the principal focus. The principal focus have a symbol represented for it, which we call it the F. Parallel rays here for the light, they are reflected through the principal focus of the concave mirror, and the distances taken from the focal principle or the focus till the center of this mirror, we call it the focus, the focal lengths. A convex mirror here is different. We are using the convex mirror. This is the shape for the convex mirror. This is the reflecting part, and this gray part is the part that doesn't reflect the light rays. It's not the shiny one. So a convex mirror here, they are used to make the light diverged and pushed away, and you can see the errors when you are speaking about any diverging point. The light rays falling parallel like the same, but they are not concentrated. They are reflecting back away from the mirror, and the convex mirror here is different because the focus is not in front. The focus is made back of this mirror, and the focal length again will be the distance between the focus and the center of this mirror. We have different ways to cause the images to be formed by the concave mirror. We have like 5 shapes of it, and or 5 cases, and convex mirror only have 1 case. If you want to make an image formation by the convex or concave mirror, we will start with using the concave mirror here, the principles of how they are images formed inside the concave mirror. The first part that you have to put the object, as you could see on the top of this part, and it's away from the center of the concave shape, because this mirror is apart from an entire circle. So we say this is the center of the circle where the mirror has been cut off, or the curvature, and the focus here is the point where the found as the point where the images or the light rays are collected. So you have to, if you want to get the image, write first and draw it, the object to be on this part as this shape. This is the object in front of the mirror, and 2 beams are moving out from it. Because it's near object, we are not using entirely parallel light rays, we are using only 2 beams. So one of them will be parallel to this line, which is the principal line, and the second line will pass by the focus. So I have 2 lines here, or 2 arrows will fall on this mirror. One of them is parallel, second will pass by the focus. The first one on the top, when it's reflected by the concave mirror, it has to pass by the focus, as you could see down, and the second one which passes by the focus will be parallel, reflected parallel to this point. And these are the two rules for the reflection when you are using the mirrors. Then you can see here that when the two arrows reflected, they will be focusing into a point, they will attach together, meet at a point. This the point where the image is formed. We call it here the image at the top of the object. But you have to understand, when they are connected, all of the body must be at the center line, which means the head is down. That's why the image is being formed like this. And if we will speak about the shape of the image to be formed away or more than the double of these focal lengths, or more than the center of this mirror, we can say that the image, when it's formed, it will be inverted totally. It's going to be smaller than the object, and the image has to be real, not virtual. Real because it's made by the conduction of the reflection of the light rays. This is the first case for it, and you can see how they are formed by this simulation directly. The second case to go through it would be like this. First one here to be on the center line, or the center point away from this mirror. The center point here, it equals the same focal lengths, but you have to make it twice. Okay, the distance from C to F equals the distance from F to the center of the mirror. So if I put the image or the object at the center here, and the two light rays are moving, one of them is parallel, second is passing by the focus. When they are reflecting back, they will be conducting together in a point at the center of this image. We can say the description for the image here to be inverted, real, and equal in its size to the object. Okay, while if you push the image, or sorry, if you push the object a little bit less than the center, more than the focal length at this part, you will find that the light will fall firstly parallel to the line down and passing by the focus. So when they are reflected, they will come together and meet at a point away from the center of the curved shape. And we can say that the image, when it's formed, it become magnified, it's larger, and it's real because it's made by the reflection of the light rays, and it will be also inverted. This is the second and the third part. Fourth part here, if we put the image, the object on the focus, there's no image will be formed, by the way. Why? Because the light ray here, we cannot pass it by the focus down. We have to pass it by the center of the mirror. When it's reflected, will be reflected in this shape, and the line that is parallel on the top will be reflected with this shape. So they will be parallel to each other here. So there's no image to be formed because they didn't meet at a point. They didn't meet at a point at all. So if this is the fourth shape or case, and the last case here, it's the same one here down. When it's near, very near to the concave mirror, which is less than the focus length, the object will have two beams. The first one will be parallel, second one will be falling away like this to be reflected back to the focus as an extension. But the line will travel from this part reflected to this one, and it will the second one here will be reflecting back to the focus down. We can say that they will not meet or match at the shape of the mirror in front, but it will be formed on the back. We said here that the image, it's upright, it's not inverted. The image here, it's not real, it's virtual because it's made by the extension of the light rays. And the third one is that it's larger than the size of the body. You can check here how the image is being formed from this simulation. The two beams are moving out of the body, and they are connected at the back of the mirror, not at the front. So if we are going to speak about the second type, the convex mirror, there are only one case, but when you speak about how it's falling, this is the shape where the convex mirror is being made. All of the parts inside is not reflecting, but the parts from outside here, it's reflecting. So if I put an object over here, the two beams, one of them will be passing parallel, the second one will have an extension to be in the focus at the back. So we can say that this light ray, the parallel, will be reflected away because it's divergent, and the second one, which focus and passing down here, it will be reflected as a parallel. So they are not going to meet at this shape of the mirror, but it has to be made at the back of the mirror. The image will be formed here in the extension of the images. That's why when we are collecting all of the parts here for the image to be made, as it's made from extension, it's again will be a virtual image, not real. The image will be upright, it's not going to be inverted. As you can see, the head of the object equals the head of this image, and the image is being made smaller in its size than the object. This is the only case for the convex mirror. So we have 5 cases for concave, 1 case for the convex. How can I use the concave mirror? Mostly of the concave mirror being used as a collector or converging for the material or light beams, or what are used for to come up with the entire parts to be focused in one area. You can see here that mostly of the satellites collecting energy for the TV sets. Also the bat's ear here, it's always concave because it's collecting the sound energy and sound rays. And also concave mirrors here are used sometimes to magnifying the images of people then when they want to see anything through it, but this happens when you are close. The only one used for the convex mirror here, we can see that the convex mirror, it's always being producing this type of the image, virtual, upright and small, and this image is always diminished, it's like smaller than the object. So we are using the convex mirror sometimes to be useful to find a wide field of the viewing, such as the car driving mirror, or a shop security mirror, or even the one that you can see while you are driving your car into the road, because it's expressing for you the far objects to be in front of you as a mirror being made of convex shape. Here we can find some questions. If you are using the curved mirror, so it's a reflector for the concave or convex. Second one, sketch a ray diagram for the falling objects on this satellite. And the third one, is this the same type of the reflector used for shop at the security mirrors? And you have to explain it. To answer this, first one here, it's concave, it's not convex. If you want to sketch the ray diagram, all of the light rays, as you can see, they are parallel and they will be focusing on this antenna, which is the point where the focus is being made. And you can find that the answer here, it's not the same. Why? Because this one is concave, as we can see, but the mirror that are used in the shop security, it's convex. So this one using an image, making an image which is make a small angle view, but the other one makes a wide angle view. You have here some questions, you can go through it, and these questions can be answered directly inside the Google form and also the Google Classroom. Thank you so much, and let's see your answers. Bye.